According to the National Electrical Code, specifically Section 250.148a, bonding the conduit to a ground fault circuit interrupter, or GFI, receptacle is an acceptable method when a grounding wire was not initially installed. This practice provides an effective grounding path, ensuring electrical safety for the outlet box and any devices connected to it. The principle behind grounding is to provide a low impedance path for fault current to return to the source, thus tripping the circuit breaker or fuse and de-energizing the circuit. A ground fault is an unintentional electrical path between a source of voltage and ground. This can occur when insulation fails or when a live wire comes into contact with a grounded surface. GFI are designed to detect even small imbalances in current between the hot and neutral conductors. When such an imbalance is detected, indicating a leakage of current to ground, the GFI trips, interrupting the power supply and preventing electrical shock. Grounding the electrical system is a crucial safety measure. It protects individuals from electric shock hazards and minimizes the risk of fire caused by electrical faults. In a properly grounded system, any fault current will flow back to the source through the grounding path, causing the overcurrent protective device to trip. This rapidly cuts off the power to the circuit, preventing the buildup of dangerous voltages and currents. The National Electrical Code, or NEC, provides comprehensive guidelines for the proper installation and grounding of electrical systems. It outlines the specific requirements for grounding different types of equipment and systems, as well as the acceptable methods for establishing a grounding path. Section 250 of the NEC covers grounding and bonding requirements in detail. Bonding refers to the practice of connecting together all metal parts that are likely to become energized, creating an electrically conductive path. This ensures that all bonded metal parts are at the same potential, reducing the risk of electric shock. In the case of GFI receptacles, bonding the conduit to the receptacle provides a direct electrical connection between the conduit and the receptacle's grounding system. This connection allows any fault current to flow through the conduit back to the source, tripping the breaker or fuse. When a grounding wire is present, it serves as the primary grounding path. However, in situations where a grounding wire is absent, such as in older installations or when it was inadvertently omitted during construction, bonding the conduit becomes a viable alternative. The conduit must be metallic and properly connected to the outlet box and the electrical panel to provide an effective grounding path. The connection points must be clean and free of corrosion to ensure good electrical conductivity. The NEC specifies the types of connectors and methods that are acceptable for bonding conduit. These requirements are designed to ensure that the connection is mechanically strong and electrically sound. When bonding conduit to a GFI receptacle, it is important to use the correct type of bonding jumper. A bonding jumper is a short length of wire or a metal strap that is used to connect the conduit to the receptacle's grounding terminal. The bonding jumper must be sized appropriately for the circuit and must be securely fastened to both the conduit and the receptacle. It is also important to ensure that the conduit is properly grounded back to the electrical panel. This can be achieved by connecting the conduit to the panel's grounding busbar. The grounding busbar is a metal bar that is connected to the building's grounding electrode system. The grounding electrode system provides a connection to the earth, which serves as a reference point for electrical potential. By connecting the conduit to the grounding electrode system, any fault current can flow safely to ground. The NEC also specifies the minimum size of the grounding electrode conductor, which is the wire that connects the grounding busbar to the grounding electrode. The size of the grounding electrode conductor depends on the size of the service entrance conductors. In addition to bonding the conduit, it may also be necessary to bond other metal parts in the vicinity of the GFI receptacle. This includes metal faceplates, metal boxes, and any other metal objects that could become energized. Bonding these metal parts ensures that they are all at the same potential, reducing the risk of electric shock. The NEC provides specific requirements for bonding different types of metal parts. These requirements are designed to ensure that the bonding is effective and safe. When working with electrical systems, it is always important to follow the NEC guidelines and to take appropriate safety precautions. This includes wearing appropriate personal protective equipment, such as gloves and eye protection, and energizing the circuit before working on it. It is also important to have a thorough understanding of electrical principles and to be familiar with the NEC requirements. If you are not comfortable working with electrical systems, it is best to hire a qualified electrician to do the work. A qualified electrician has the training and experience necessary to perform electrical work safely and in accordance with the NEC. They can also help you to identify and correct any electrical hazards that may be present in your home or business. Understanding the importance of grounding and bonding is essential for ensuring electrical safety. By following the NEC guidelines and taking appropriate safety precautions, you can minimize the risk of electric shock and fire caused by electrical faults. Bonding the conduit to the GFI receptacle, as allowed by NEC section 250.148a, is one such method to achieve this safety goal when a grounding wire is not present. Always consult the latest edition of the NEC and local electrical codes for the most up-to-date requirements and regulations. Remember to verify the integrity of the entire grounding system, including the connections at the panel and the grounding electrode, to ensure that the alternative grounding path is fully functional and compliant with safety standards. It's crucial to understand that while bonding the conduit can be an acceptable alternative, it relies heavily on the integrity of the conduit system itself. If the conduit is not properly installed or if there are loose connections, the grounding path may be compromised. Therefore, careful inspection and maintenance of the conduit system are essential to ensure its effectiveness as a grounding conductor. Firstly, inspect the conduit for any signs of damage or corrosion. Secondly, ensure that all connections are tight and secure. Thirdly, use appropriate connectors and fittings that are specifically designed for grounding purposes. Remember that electrical work can be dangerous and should only be performed by qualified individuals. If you are not comfortable working with electricity, it is always best to consult with a licensed electrician. They can assess your situation and provide you with the best possible solution for your electrical needs. The goal is to establish a reliable and safe grounding path, whether through a dedicated grounding wire or through the conduit system. This ensures that any fault current will be safely conducted back to the source, minimizing the risk of electrical shock and fire. Grounding is not just a matter of convenience, it is a fundamental safety requirement that protects people and property from the dangers of electricity. Understanding the principles of grounding and bonding is essential for anyone working with electrical systems. It allows you to make informed decisions and to ensure that your electrical installations are safe and compliant with the NEC. The NEC is a living document that is constantly updated to reflect the latest advancements in electrical technology and safety practices. It is important to stay informed about the changes and to ensure that your electrical work is always in compliance with the latest edition of the code. In addition to the NEC, many local jurisdictions have their own electrical codes and regulations. These local codes may be more stringent than the NEC and may include additional requirements. It is important to be familiar with the local codes in your area and to ensure that your electrical work complies with all applicable regulations. The use of GFI receptacles is another important safety measure that helps to prevent electrical shock. GFI receptacles are designed to detect even small amounts of current leakage and to quickly interrupt the power supply. This can prevent serious injury or even death in the event of an electrical shock. GFI receptacles are required in many locations, such as bathrooms, kitchens, and outdoor areas, where there is a higher risk of exposure to moisture. It is important to install GFI receptacles in all required locations and to test them regularly to ensure that they are functioning properly. Testing a GFI receptacle is simple and can be done using a GFI tester. The tester plugs into the receptacle and simulates a ground fault. If the GFI receptacle is working properly, it will trip and interrupt the power supply. If the GFI receptacle does not trip, it should be replaced immediately. Electrical safety is a shared responsibility. Everyone has a role to play in preventing electrical accidents. By following the NEC guidelines, taking appropriate safety precautions, and using GFI receptacles, we can all help to create a safer electrical environment. Remember, electricity is a powerful force that can be dangerous if not handled properly. Always be careful when working with electricity and never take unnecessary risks. If you are unsure about something, it is always best to consult with a qualified electrician. The proper grounding and bonding of electrical systems are crucial for ensuring the safety of people and property. NEC Section 250.148 provides a specific allowance for bonding conduit to GFI receptacles as an acceptable alternative to a grounding wire when one is not present, emphasizing the importance of understanding and adhering to electrical codes and safety practices. Always consult the latest edition of the NEC and local electrical codes for the most current requirements and regulations. Ensure that the entire grounding system, including connections at the panel and the grounding electrode, is fully functional and compliant with safety standards. Regular inspection and maintenance of the conduit system are essential to maintain its effectiveness as a grounding conductor.